like I said, it's not hard to do. It's more a question of interpreting it.
There's no one put in their age to test.
Yes, that's right. So the data, but that's a good observation. That sometimes in data sets, I prefer to calculate the age based on the date of birth and the date of visit. But here, obviously, they were asked, what's your age to the nearest year? Or they rounded it off that way and threw away information before they created the data set. And I'm not sure that was wise to do. But
in this plot, 14 and 15-year-olds have both fit under 14.
in this plot, there was no one at 15. Oh, no, sorry, I take that back. In this plot, it's using the decimal point.
There was no one that was 15.
No, I think it's doing it, it's bended in groups of two. It's grim.
Groups of two.
Yeah.
So 14, 15, 16, 17, 18,
Yeah.
44, 45.
So anyway, that's an antiquated plotting system. But
Dates dealt with in R.
okay, so so there's two different ways. If you read it from a .csv file, that's a very good question. It's just interpreted as text, okay? But dates in Excel, for instance, use what's called a POSIX system, which is the number of seconds since January 1st, 1900 on Windows and January 1st, 1904 on Macintosh. And I have known people who had to withdraw papers because they did all their date calculations in Excel and they kept moving back and forth and they didn't realize that there was a difference. And Microsoft has since abolished that difference, but those were in the days when they were trying to make the Mac as unusable as possible, and it really created confusion. So if you read from a .csv file, you get a text string. And you can use the asDate function to convert that to a date using our system, which is called POSIX. And it's the number of seconds since January 1st, 1970. But once it's a date object, but you don't have to worry about that. You can subtract dates, and you'll get it in days, the number of days between visit and birth date. And so I prefer to do all my calculations in Excel and then import it as the age. So then I don't have to declare it as a date in R. I have this numeric variable age already calculated. But if you want to import the original dates, if you use the read Excel function, that package, it will import the Excel formatted dates, and then and they will come into R as dates, and you can subtract them or add them.
It will come in as the number, because sometimes you get like this huge
No,
number.
it comes in as the date if you use that read Excel library. And that is, in fact, the only advantage to reading the Excel file directly is then you don't have to do the dates. But what I do, because Microsoft really every year changes their format and this library will stop working for a few months, I prefer to do my date calculations in Excel and then read in the actual page. So, but it's the reason actually I showed you the read Excel library. If you have a lot of date manipulation to do, you may prefer to do that. But I still am concerned about people using that and not knowing which version of Excel they're using and what it's doing underneath and screwing up their calculations. And it really is embarrassing when you have to withdraw a paper because all your ages are wrong. And I do have a colleague who had to do that because she was using Excel for calculations. So. But the asDate typecasting will take a string, 12/6/16, and convert it to a date. And you can specify the format, the separator, it's a backslash, what comes first, months, if you wish. We're now going to talk about XY plots using the formula notation. So the plot function here, I'm plotting birth weight on the Y versus maternal weight on the X, and specifying the data set, and you see I get an XY plot. You'll remember I told you earlier that if you take a categorical variable and you unclass it, it turns the categories, in this case white and non-white, into numbers. And I can use those numbers here in my color function to color code. So I add information to this plot. It's no longer a simple XY plot. I now have color coding to tell me which are the non-white babies and which are the white babies. And so it turns out in this case, 1 is white. Those are the black dots because our color table that we looked at. I mentioned earlier that this AB line function is actually quite useful because here we haven't learned how to do this yet.
So has everybody got the black and red dots?
Good question.
Yep.
Everybody got the black and red dots?
So
Not yet.
I think you're just like at a different Zoom.
Yeah, here's your, they look like they're black.
But like, I don't understand how you read what's on your computer.
Oh yeah, you can do Command plus. You can do Command plus to blow up the text.
No, she's a PC.
Oh, well, the Control plus.
Control plus.
But like in general, I feel like
She has better eyes than you.
Jonathan, this is not the time.
No, it's like, it's like about a 7 font.
it's really
Oh, you can go to preferences and set the font
Oh,
size.
I think she wants it, that's fine.
Oh, okay. Far be it for me to intrude.
Jonathan's just being
My old eyes.
an eyeist, if you will.
So I told you a minute ago that
So we're just waiting, so I've got black and empty, and then you want black and red.
we're good, no? So everybody good with just, it's a very, I mean, it's a trick really to show you how to color code, add some information to your plot, so. We're still having, yeah. It's kind of embarrassing, I don't know how to spell intercept.
Makes you feel any better, I read that as intercept.
Thanks.
It's that saying, like, if you the first few letters and the last few letters, you just go.
makes no difference.
Confirmation bias or something. I mentioned a minute ago, so I'm just going to repeat it here, that that this AB line function is really useful for prettying up a graph because, for example, here I'm going to do a linear regression using the LM function. I'm just going to do this regression of birth weight against pre-pregnancy maternal weight, and it's a simple regression. I'm calling it Model 1, and when I ask to look at the summary, and we're going to do regression next week. Don't worry, yeah, whatever you want to call it is fine. This is the summary. It shows me the intercept and the slope, but R is smart enough that now I can say use that line function, AB line, to add the regression line, and I don't have to say the intercept is this and the slope is this. I can just give it the model that I just fitted, and I can add the regression line to it. So that's a good trick. This I don't expect you to really know, but I just wanted to add as an example. You have shown your competence at calculating correlations. Well, here I'm going to calculate the correlation, which we saw earlier, and I'm going to use this, I'm going to create a little bit of text by pasting together that correlation with a bit of a description, and I'm going to add this line R equals 0.19 to my graph using the text command where I just say what the X and Y coordinates are. So I don't expect you to do that, but just so you know that you can do that, so I can pretty out my graph. I can add a correlation right to the graph. We talked in our theory session about why it's nice to add lines to graphs. So this is the best fit linear regression, but we talked about how do you assess the linearity, and there was a lowest plot, which is a lowest smooth, which is a moving average that allows you to look at, it's called a non-parametric, non-linear smooth. And here I'm just saying, use this lowest function, calculate the best smooth line between birth weight and maternal weight, and add it using another layer and the lines function. And you can see in this case, what would you conclude based on your comparison of those two lines?
That the higher weights and the middle weights tend to fall around the same level, or they even out. But at the lower weights, there tends to be a lower, what is it again?
And that is correct. Though in this case, and this is a judgment call, obviously, or a personal opinion even, I think that's close enough to linear that I would have no disquiet.
That bottom number is throwing the whole line
Yeah,
off.
that's right.
Yeah.
Yeah. So I mentioned, I think, in the talk that I like to put both of these lines on the graph just so that, because I find it easier to then say, oh yeah, I'm okay doing the linear approximation. And it's so easy to do. I can pretty it up using the legend command that we talked about the other day, and again, it's just there as an example, and so I now have a nice graph showing the best non-linear fit and the best linear fit. and the correlation. So by adding layers to our plots, we can actually create fairly informative and detailed.
Is there an easy way to remove layers from the plot without having
No,
to
you have to
start
go back
again?
and run, but because you have your command history,
Right, you just copy and paste it again. Okay.
or just
Or
go
just
back a
redo
few
it.
steps. And in fact, I mentioned this the other day, but it's very easy to step back to previous commands from my output window. So I can easily go back, even if I didn't save it. And over here, you also have your command history of everything in this session. So there are several different places where the commands you've run are saved. Typically, we do it up here, where we're writing our commands in. We've been looking at relationships between numeric variables. When one of our variables is categorical, we talked about how the graphical exploration typically involves box plots for a comparison of a numeric variable by category of a categorical variable. So this is a box plot where we're going to look at birth weight for each race category separately, and I'm adding some axes labels, and you can see I get a nice box plot, and this is the 5-number summary: the median, the first quartile, the third quartile, the range, the outliers, all graphically depicted in one simple plot. So I would like you now to use that box plot function and instead look at the distribution of birth weights by maternal smoking category. And before you do it, what do you expect to see? Just based on your clinical knowledge.
Smoking.
Yeah. That's what we would hope to see. So you should now, with that template, be able to very quickly
It comes up.
Is it smoke?
Yeah, it's smoking.
Yeah, sorry, the variable is smoke.
It's not as big a difference as I was expecting.
But remember, actually, I don't think we've talked about this yet. This is an unadjusted rate. We haven't yet looked at the effect of race, and there are racial differences in smoking habits. And in fact, as we'll see when we talk about regression models, that smoking is a confounder for the relationship between birth weight and race, and that's where regression models, I know you learned all about confounders from Dr. Zad, but we'll show how in a regression model you can tease out those effects. Everyone got that box plot? Is that what you expected to see? More or less. So let us go on other way. We talked about contingency tables and how you create tables of counts, and we created a number of them, and you'll remember that we named them so that we could use them later. So in this case, sorry, let me get rid of that line. In this case, table 1 or tab 1 was just the counts in each race category, and once I have, this is a vector or a column, once I have a column of heights, I just apply the bar plot function and I get a bar chart. So it's like a histogram, except the bars don't touch each other because these are discrete categories, not continuous bins.
Would that work equally well on the column in our data set?
Yes, on any column, if it's a column of counts, yes. Yes. So in fact, as I've shown here, you can specify height equals whatever variable you want. So it could be, if you've got a counts, like the number of, for instance, the number of visits to the doctor in the first trimester, which was one of our columns, we might want to plot that as a bar chart. In this case, table 1 that we created earlier was was just a vector, but table 2 was a 2-dimensional table where we had separate rows for each birth weight category. And the bar plot function, so that's called a matrix. The bar plot function works just as well on a matrix as it does on a vector, the difference being that I now get what's called a stacked bar chart. So I get the counts, not just by race category, but I have low birth weight and high birth weight. And what you should appreciate here is what's striking about that other category, which in the US is going to be mostly Hispanic, or actually non-whites in general. Does that surprise you? we commented on this in the table, that there's just more low birth weight in non-white families in the U.S. So this is just a great way of graphically showing that relationship. And for publication, we could do it with colors. For publications, it often is nice to use this density option to create shaded lines. But these days, with electronic publication, even colors aren't a problem. And of course, all of those decorative plot options we've been talking about for titles and colors and axes labels apply to bar plot just the way they do to the other plot functions. So, and we can add legends exactly the same way. So again, by adding layers, we can create these, and my goal here is really just to give you some templates that you can use. Some people don't like vertical bar charts, and so there's an option in bar plot for horizontal. So you just set horizontal equals true, and it flips the chart. Some people don't like stacked bar charts that we saw a moment ago, and there's a beside option that creates what's called a grouped bar chart. So instead of being stacked on each other, and maybe it's easier to interpret this way, we see low birth weight and high birth weight, or normal birth weight as adjacent bars. And again, we can add legends and labels and all of these things. So these commands tend to share a common syntax. The decorative elements are the same. So in fact, I would like you now to create a stacked bar plot to look at the distribution or the number of low birth weight babies based on maternal smoking habits. Did it ever? Did it ever? Okay. So she did it? Oh, okay. I'm sorry. Oh, it's okay. I just lied. So remember, first you have to create the table, which you made a moment ago in an earlier exercise, and then you have to apply the bar plot function to it. And you can do that all in one line or in two separate lines. So when I did it, and you don't need to follow my example, I used my table command to first create a table to cross-tabulate low birth weight and maternal smoking, and I called it table 5. And then I applied bar plot to that. And you'll remember the stacked bar plot is the default plot, so low birth weight and normal birth weight will be in the same bar, but shaded differently.
So I did the smoking, but I didn't get it the double.
Okay, so then you use beside equals true.
Okay. And I had that in the same as.
Yeah,
and that will
yeah,
be okay.
you can make that a little bigger if you want this.
Oh yeah, no, I made it smaller earlier
Oh, okay.
because I was writing a
Yeah,
whole bunch of
yeah.
notes. Okay, thanks.
So Suzanne was just asking how does she, if she doesn't like the stack bar chart, how does she make a group bar chart? So that's the beside equals, so the category, the subdivisions are shown adjacent as here. So
What's the difference between bar plot and bar chart?
nothing. They both generate similar.
You did something wrong. I don't know what. No, 5. No.
Yeah, that's nice. Flip it over, make it group.
Why are you using D2 instead of D? I think your D2 is a data set where everyone.
That's where we subset
No one
normal.
smoked.
Didn't know smoke, that's right. We got rid, so when we created that data set, we got rid of all the monitors who smoked, which, so your graph is accurate, but this is actually important to see how easy it is to get confused with which data set you're working with and why the ability to specify data sets makes a difference.
Keeping them separate.
Yeah. And so you just need to change the name. You've got your line there, it works fine. You just need to change the name of the data set when you create the table. Everybody looks like they've got that. Nice, pretty. And again, the point here is to look and say, yeah, the proportion of low birth weight babies born to mothers who smoke is, as I expected, higher. And this visual inspection precedes tests of significance and comparison to mean birth weight and things like that, which is what we're going to do next. In fact, the next 10 or 15 lines is how we compare means using t-tests and ANOVAs, and how we compare proportions. And I think I'm going to leave that to the next day, because that's the luxury we have in Palisalia has scheduled this.
So not sample size on Monday?
No, so the next lab, yeah, so,
Unless you Wednesday, then I think.
no, the next lab is Friday.
Is it, because then
Yeah.
you do regressions?
Yeah, so on Wednesday, I'm talking about regression, on Friday, we're doing the lab. So at the beginning of the regression lab, we'll finish this, and in the meantime, what I would like you to do is to import that child test, scholastic testing data frame, format the variables, there are instructions in the primer, and read the primer on comparison of means and proportions. So if you can work through these, you can see it's not very many lines. It starts here at on comparing means, line 203 in my version, and it goes for 40 lines on comparing count. So if you can work through those examples, then we will go over them in the lab. And if you have any questions or problems, Celia's written my email address on the board back there, and I am more than happy to help. I mean, I'm happy to talk on when I'm here on Monday, but I'm happy to. I'm happy for anyone to email me, and I know you're having problems with Cara. Maybe you could just drop me an email, and we can go back and forth. Okay. Any questions? Any comments? Is this helpful?
Yeah.
Okay. Good. The purpose is, as we said before, to make you comfortable doing these and to give you a template for doing it with your own data, and I hope that we're accomplishing that.
When you're making legend,
Yeah.
what does the BTY and this?
Just whether BTY is just box, and so around the legend, do you want a box? I hate those lines around the box. That's the only
Yeah, it doesn't
one.
look
Yeah,
right.
exactly.
And the CEX.
CEX is how big the text is going to be, and it's as a proportion of the X in whatever font you're using. So if it's 0.8, it's going to be 80% of the standard X size. If it's 1.2, it's going to be 120%. So these are all, when you look at the help, you'll see these are all kind of explained, and I've tried to give you some examples of what they do, and you can fiddle with the numbers and see what you find most attractive. But one of the flexible points of writing commands is that you get to customize according to your own
Is there an
aesthetic.
easy way to capitalize the no and the yes? That's just me just looking at it.
Oh, yes, in the legend, you can change so the legend equals, you could just put capital N-O.
But they're the X.
Oh, here.
Yeah.
Yes, so if you go to the help on bar plot, by the way, bar chart is from a different graphics library, it's not a core, whoever was asking about that, and so it does the same, but it's from the Lattice library. I wouldn't go there, just because we haven't talked about it, and it's not my favorite graphic package. So, yes, there's a there's an option in bar plot that allows you to rename the categories on the x-axis, and I don't even remember what that option is, but it's called arg names or something.
Names.org.
Yep, that's it. And so there, you could create a column, C with parentheses, and you could rename them. So, yes, I mean, and we've tried to stick with sort of basic functionality here, but every function we've dealt with has an enormous number of options. And either the help or some of the online resources will help you. I'm sorry, Liz, I don't want you to take your time. I will stop.
Did you want to help just with the car library right now?
I don't want to intrude on Liz's time.
Well, we have until 12 o'clock, and I think people can take a bit of a...
Yeah, oh, okay, sure. Yeah, no, I'm happy.
Yeah, is that okay? I'm just gonna load up your...
Did you bring her card? So